community. You're always breaking GNOME. So take it away. Is the mic?
Oh. Yeah.
Oh. Okay, keep talking, Jordan.
Oh, can we start? Oh. Hello everybody. I hope you're always breaking GNOME talk, which the title is a bit misleading because during the talk we figured out that we'd rather talk about all the exciting GNOME things that happen in GNOME OS, but it started originally as what happens and how we actually build GNOME and why you always break it. But in order to do that, in order to build GNOME and test it, we have GNOME OS, which is well, the slides will gonna yes.
Big blue button.
So we have GNOME OS, which what GNOME OS is an operating system distribution we use to test GNOME and figure out when things, how are things working, if they are working. That is, it's an independent distribution. Well, it's not. It's an operating system. It's distribution independent, meaning that we do not base it on Ubuntu or Fedora or anything else, as GNOME has to be vendor neutral, and we don't want our tooling to be specific to any distro. We want everything to be we want everything to be, independent and functional, and make sure that things will work regardless of the system you are on. It's built from scratch. We'll see later it's based on FreeDesktop SDK for a lot of things, but everything is built from scratch, from the kernel all the way to the user space. It's as much reproducible as possible, and this is quite a really nice property to have in testing system, because we have a lot of bugs, but at least they're reproducible bugs, and we know about them. And it's very experimental in the sense that we do not make any stability claims, and from time to time we might break your system. So yeah, we also transition from the technology to technology. For example, the latest things we will see about today are about all the new and exciting things that have to do with security and redefining how we compose an operating system. GNOME OS is mostly for developers, designers, in order to build and test their changes. So, for example, developers often need to have newer versions of glib or GTK or anything else when they're testing their things. And GNOME OS builds everything from Git and as latest as possibly we can. It's also for designers, so designers no longer have to mess with how they build something, how a component is, how you need to compile a program, an application, the shell itself. They can just boot up the virtual machine and see how things are progressing, or what landed, what needs fixing, what's broken, and all that. We also use it for marketing purposes. As you see in this screenshot, it's like a screenshot of the 47 alpha release we did a couple of days ago, which obviously is not out or anything, but we take material out of it for the release video. We take screenshots. We can eventually we hope to have a press kit at some point. It's also for people that want to test things, and anyone curious enough that wants to hack around on operating system itself and see how it's built. What GNOME OS is not is a general purpose operating system, as its scope is mainly for development and extremely limited. And due to that, there are a lot of things that are missing. A lot of things are not stable. We might eat your work. Your machine might stop booting. However, we try very hard on making that as recoverable as possible, and we're looking into building the operating system in a way that's as recoverable. So even when things go wrong, you can you have such guarantees that you can easily get back to a working state. And at the moment, it does not have a security team, as it's like a very, very small team of us that maintains it. And we are mostly interested in like trying to have everything working at the time, and there is nobody like looking after security updates, CVs, and all that. As we do not expect people will use it on for real work or rather for certainty work. How we build GNOME now is another question, because it has to do a lot with the GNOME release team, which is in charge of keeping GNOME building, which sounds easy, of course, like think software will like build itself, but when you talk about like 200 plus modules that make up all of GNOME, things can very, very easily go wrong if one module stops compiling for whatever reason, or there is like a big transition that we might need to do and land a couple of things at the same time. The release team is there to make sure that everything keeps compiling. So whenever you start compiling locally yourself, everything will just work, and hopefully you will never have to see a weird build failure like you used to when with GHB and all that. That also we also like use that when we create releases for distros to pick up. We need something that to make sure that all the components, all the releases, all the latest tags will work together one with another. The release team uses the repository linked here, which is GNOME build meta, and it's a lot of build definitions and the sources that we use for its build. It's a build stream project, and with that come a lot of different things we take advantage of. And it's a quite flexible tool, because from that repository, we both create the releases to make sure everything builds. Additionally, we build the Flatpak runtimes from that and GNOME OS itself. So everything is built from the same sources, the same binaries. We have like a nice content addressable server of all the builds. So builds are pretty fast, and we don't have like to rebuild everything every time. And there are like a lot of future plans we have for that as well. In addition to like the Flatpak runtimes and GNOME OS, eventually we want to like publish the SDK, the runtime documentations, or check for ABI breakers. Or another idea we had at some point was exporting all the object introspection definitions somewhere, so binaries could consume that from the canonical source or other things like that. But yeah, all that's our future plans. So GNOME build meta, as I said, is a build stream project. What happens is that we have like basically an element for almost every project that makes up GNOME core, that is, and we try to track the latest change we can. So let's say every day or so, or maybe twice a day, we will check, we will pull down all the changes on GTK, on glib, on Cairo, or whatever. We'll try to build them. If the build succeeds, it automatically gets deployed. And we push out the Flatpak runtime and GNOME OS builds that way for others to consume the nightly builds. This is the part that always breaks and the source of the talk. But yeah. Additionally, from the same exact repository, we also manage stable releases, where instead of like pulling everything from Git, we just pull the latest tarball release or the latest tag of its component. Again, test them, build them, push it. It's all of it is based on FreeDesktop SDK, which is part of why, because it started off as just building the Flatpak runtimes, which were at the time that, and then we said, oh, well, we can just use that for GNOME OS as well, because we can totally just build an entire operating system with that. Even though it's like just like a base for the Flatpak runtimes originally, it can be easily extended like that. Our team is very small. It's basically the GNOME release team, which is like a handful of people that keep track of all the things in GNOME that needs to be updated, and all the modules, and fix all the build failures and all that. And additional to that, we usually have, there's Valentin and Adrian who take care of how GNOME OS itself is put together and composed, and the source of a lot of the changes we'll be discussing later. Sam as well, who takes care of the OpenQA. And yeah, we also, like the release team takes care of a lot of the CI that we create as part of these things. And yeah, that's about it of GNOME OS. And with that, I'll give it to Valentine for the general updates on how we composed GNOME OS itself.
Yes, let me fix the presenter. Yes, so the big thing that was new in GNOME OS since last year, this is the move from OS 3 to sysupdate. So since 2019, we have been using OS 3. This is to deploy updates to your installation of GNOME OS. And it's been very useful and worked very great. So we had an atomic distribution. So could just every time there was a new build on master, it could be deployed on your machine at once without big problems. But we have for a year we have been testing sysupdate, which is a tool that comes from systemd, and OS 3 is great, but the fact that it's a different tool from systemd, and systemd has all its tools are moving ahead together. Using OS 3 together with systemd has some limitations. There was a few things that were not working like we wanted, and because we had to wait for OS 3 to catch up. But because we are not a distribution, we are an operating system that is bleeding edge, we want to use a lot of stuff from systemd. So it's moving to sysupdate was good for us. So I hope we will drop OS 3 so we don't have to deal with two different deployments, but we'll see what happens. So systemd sysupdate comes from it's a part of the IDE that in systemd they had. Lennart has published some blog post about that, about how a modern image-based Linux should be. And the big points are you have an AV partition and you need to be able to update. So this is very simple way to update. So you just have a /user partition somewhere, and when you want to update, you have another partition on your disk that will receive your update, and you reboot and switch to that. This integrates, everything integrates very well with systemd boot, and there is something new which is like called the unified kernel images that we have been able to use now, but we were not able to use with OS 3, which is a signed EFI binary that contains the kernel, but also the uniform FS and a lot of metadata. So we don't have to care about boot entries to in the bootloader, but only just drop one kernel file into the bootloader. And along with this, the distribution. So we have a distribution of unified kernel images, but also DDIs, discoverable disk images, which is a generic way to have an image that we know what to do about, how to mount it and everything based on itself. So everything now with the sysupdate version of GNOME OS is distributed in one of those two formats. And all this came with measured boot. So on your computer, you have a TPM, which is a small device for security that can do wrapping of keys, so it can encrypt your keys. And this can be used for full disk encryption. So the idea, systemd unifies a bit all these different things with all the tools that are available there. One of the things that we had in OS 3 that was very useful was to have branches. So we had two flavors of GNOME OS, which were built together, but we have what GNOME should be, and then we have GNOME with all the development tools that a GNOME developer will need. So that was distributed as two different branches. So you could switch from one branch to another and reboot with all the development or not. For the world of sysupdate, that doesn't work very well because the development is quite big and you need to store that in a raw data partition and not this in a small partition because of the AB partition thing. So for that, we have used another tool that came also with systemd, which is called sysext, which is a way to overlay extension to your file system. So when we build now, we build the user partition as a normal partition, and then the development tools will put it on the layer, and we distribute that together, and the installation of GNOME OS will download whatever it needs. And right now, the sysupdate version of GNOME OS, we do have secure boot working with a signed boot chain. So we use custom keys, of course, because this is a development project. There is no we don't have security team, so this is not signed by Microsoft keys. So if you want to use secure boot, you have to unroll your keys on your computer, which is not a very difficult thing to do. And the /user is dmverity, so the root hash is embedded in the UKI that is signed, so we know that the whole boot is secure, because when it has booted, we know that everything that has booted was coming from a build that comes from RCI. And with this, we have the transparent full encryption that, so on the first boot, it will create the partition, encrypted partition for you. It will do the encryption, and it will seal with the TPM if there is a TPM, and you will never have to care about it. You might have to enroll recovery keys so you don't lose your data if you change motherboard or something like that, but that's it. And we do have our sysupdate images are deployed. So this is a very simple thing because it's just the HTTP servers that we needed. So it goes with the CDN, and so you do get, if you have sysupdate version of GNOME OS on your machine, you do get updates directly from master. There is still some rough angles here. The deployment of sysext is still a bit broken, and it's hard to discover how to enable the development extension or other extensions. So there is some work there, but there is some agreements and some work that is going there, so it's a good thing. We are missing in the big picture of this new modern distribution. Systemd Homd is used to deal with home directories, and even though we have that thing because we have systemd, it's like most of distribution, you have to do it manually because it's not by default. So there's more work there. The installer is also a mess because I've done that a long time ago and we didn't change anything there. It was using the EndlessOS installer, which was great for the time, but now there are things in the picture that we don't have. For instance, how the ESP is created, it doesn't do anything there. The good news is that the funding from the SDF will solve some of this problem, and some of these are already worked on. There's Adrian and there's people from Gotthing as well working on these kind of things, and I'm looking forward to next WADEC to see all the cool stuff that will be there. I don't work on these things personally. Yes, and of course it's still run on hardware. So I do run every day GNOME OS on several machines. So when you break GNOME, I get after a few days it breaks on my machine. So I know about it. So as always, we expect UEFI computer. So the old legacy boot doesn't work. This is not portable anyway. We don't want to care about those kind of things. This is out of scope for our project. So we mainly test on AMD, but the sysupdate and it works on ARM and on RISC-V. So there you probably need some tweaks. But I did manage to get it working on hardware. I think the ARM is actually even published, so it's there, but I don't think anybody really uses it. There are things that remember that we don't do multi-OS on the same disk because this is a mess. If you want to have multiple operating system on your computer, you probably want to have several disks. something too important that I want to say that because we maintain our own kernel configuration, which is in FreeDesktop SDK part, but it's still a part of the GNOME OS development. Sometimes some people don't manage to make it run on their computer. Most of the time they have no problem, but it doesn't work sometimes because there are some maintaining kernel configuration is not that easy. So I would like some help. So if at some point you want to test GNOME OS on computer, don't install it because it's a development thing. But you should probably boot it from a USB to tell us what's not booting and what's not working. That's very nice. Also, during the year, there's new things. A proprietary NVIDIA driver came as extension, and that works. The experience is maybe not the best, but it's just important to have a way to be able to actually test GNOME Shell on this kind of drivers. So we have that there. I think there is one person using on their computer, so it must be working still because I'm not using it anymore. I just made it work and then and it's away. We talked about secure boot, and I really want to make sure that because that might be scary for some people who don't like this thing about secure boot. Because we use Shim, you can put your own keys and make a local build and switch to your local build. I do that quite often to test new things on my machine. So this is the kind of, you can have control of the computer. You don't have to rely only on RCI. And you can do the opposite where you can actually have your own keys and only build locally. Yes, and I think that was my part.
Hello, yes. Now we're gonna move on to like how to use GNOME OS for hacking and other things in your project. Thank you very much, Valentine, for the update. So GNOME OS is very, very far away from the traditional Linux distributions of today. It's an immutable OS. It has been for ever since it started, and due to that, a lot of workflows do not apply to it. Like you can't easily nowadays you can, but it's the usual thing where you mess and install something on your user and the launch things try that is not gonna work as is. We also have no package manager or like anything package for it. So a lot of utilities you might need that are not yet in the development tree. We try to add most of them, like that are useful, like Valgrind, ASN, and all those. Generally there, but you might need some to compile from source, some tool that you might need for a specific task to debug. So a lot of these are will not be there. However, we are working very hard on like figuring out decent workflows to make testing system components much easier, and our aim is like make it as easy as with this with Flatpak today. You can also like build your own version of GNOME OS with verified boot and measure boot and all that, just like we do on the CI and have like everything. However, that takes a long time because you have to compose the whole image. So it's not ideal for day-to-day development. It's mostly like just to make sure that any change we made actually is 100% working. And for other things, we usually use a faster iteration loop. What we have right now that works is either building against your host system or a toolbox image, I guess, and then using that binaries in the host system. Usually, when you have a read-only operating system, they do not give you all the development tools, the tool chains, the headers, the debug symbols, and all that. So your host system is useless. However, in GNOME OS, that's not the case. You have a development tree, or rather development with sysx, that will provide everything that's in the system and image. It will provide all the counterparts in the headers, the debug symbols, and it will give you all the compilers we use in order to compose the system. So if you want to build any GNOME project, usually you don't need any external dependency. Everything can just be built against the host system, then you can test it against the host system. However, there are like some cases where you want persistent changes. And with a read-only user, with an immutable, or rather, I should say, operating system, that's not easy to do. However, thanks to systemd again, we now have a tool called systemd sysext, where we can like create an image or plain directory even. So you can like mesh and install into this specific location and add a metadata file. And once you, on the next boot, or you can, or once you ask system that is, the whole user tree atomically, and your new changes will be overlaid to the current system. That means you can have your persistent changes with an immutable system and keep development like you're used to right now, mostly. And that is like an extremely fast and efficient iteration loop. And that means, and since it happens so early in the boot chain, it means we can test and debug almost any single module in GNOME, from GNOME session and GNOME shell to applications and libRwata and all that. As part of the SDF command again, Martin from Coding has been working on some tooling to make working with sysext and creating images out of them a bit easier for our workflows. So we have a new tool now that can create sysext image, or rather DDIs from that we fed into sysext from Meson build directories or from build stream itself. So you can either you have your custom checkout of the project and that you configured a certain way, and you want to just make an image out of that and feed it into a virtual machine, or you want to like replicate exactly how GNOME OS builds GNOME shell, for example, and take just a different version of it and deploy that into the VM. And you can do that in very trivial way. Another reason we made these utilities and wrappers so we can have the CI view. So a couple of months ago or year, I started making CI images out of the GNOME OS 3, much like we have for Flatpak nightly, which means that you can have available the user tree in a Docker image that we can directly use in CI, and then you can like make a sysext, build the sysext against that image, and then you can just take that sysext image and feed it into the VM. Ideally, we will have a GNOME simulator that we would have in Builder, and everything we develop against that, much like we do with Flatpak runtime, and then you would directly be able to learn to use whatever host operating system you like, but develop and run against the GNOME OS, but that's not there, but that's the end goal. So for module development, you can grab the latest GNOME OS image, you can put it in boxes, you can install the sysupdate variant, which is this thing at the moment, since we currently have both OS 3 and sysupdate for the time being, until we figure out all the edge cases. You will need to enable the development, the debug extensions to have the headers, but otherwise you should be good to go. You might need to compile some tools, as said earlier. And the idea is that you build against the host system and use sysext utils to create the image you need and do whatever you want with that. I have a demo afterwards to run to show you again how it works with CI. But yeah, and you basically the system keeps itself updated with updatectl and systemd. And yeah, you can install Flatbox as needed, or use some other Podman toolbox and other things like that. So for the demo, it's a 1-minute demo. It's going to be long, and then.
What about we continue with OpenQA and then we show the demo after Sam has
Excellent
done.
idea.
Yes.
Take it ahead, Sam.
Okay, let's talk a little about QA then. So you guys can hear me. Can Valentin, Jordan, can you hear me in Berlin? And I guess they can't. If I turn on the microphone, is everything going to catch fire? No, that's okay. Okay, so you guys can hear me now, I think. All right, I want to talk a little bit about QA, One of the big motivations for building GNOME OS is that we can test things as fast as we can build them, right? So if we wait for distros to do QA on the things we release, we have to make a tarball, and then they have to package it, and then we get a bug report 3 months later. Much better if we can build an operating system straight from master and test that. But of course, manually testing things is very boring, right? Who likes manually testing things? So we've been looking at how to use OpenQA to test stuff for us. Who's got the slides? Next slide. Maybe I can change the slide. Am I the presenter? Yeah, I think so. Right, I clicked the little arrow. Okay, this is great. Actually, I'm going to play a quick video. I don't know if this is going to come across on the... No, I think this will come across on the screen, right? So this is the OpenQA instance that we have. This is an example of a test. And you can see all the screenshots that it took. And I'm just going to play... One cool thing about OpenQA is every time it runs a test, it records a video. So all going well, we can watch the video of the GNOME install test. And here we go. So this is a real virtual machine. It's running the GNOME OS installer. This isn't real time, by the way. Reboot the machine, run through initial setup. The shell booted, so the test passed. We shut it down, and everything's great. And as well as the video, we can see all of the journal output. Well, actually, that isn't there, but usually we have the journal output in the serial console and other stuff. So if something goes wrong, you can kind of see what happened. Let's see. I'm not going to go into the details of OpenQA because I don't have time. Please ask me if you're interested. And there's also a talk I did last year which goes into a lot more detail. Great tool. Thank you to OpenSUSE for a lot of the work that they do in it. One really cool thing that's happened over the last year is we've set up a monthly call between different distro QA teams and basically anyone interested in testing desktop Linux. Anyone doing automated testing of desktop Linux. So it's not specific to GNOME, it's not specific to GNOME OS. And through this, we discovered that 3 distros are already doing OpenQA. So OpenSUSE, of course, Fedora also have a huge suite of tests that they run every day. That's actually a screenshot from the Fedora test suite, and they're testing all of our apps and more. And then Debian are also running tests 3 times a day. So this is fantastic. And you can join the call, by the way. It's open. So stuff that's happened in the last year on the GNOME side. We ran an outreach internship. That's Dorothy and that's Tanju, who are interns from December to February of this year. They added some more tests around apps resizing to mobile form factor and around some of the accessibility features. Still plenty more to do on that. Again, talk to me or someone else if you have ideas on more accessibility stuff we can test. We also hit a rather annoying bug in GNOME Shell that causes tests to randomly fail, which isn't resolved yet. We think we might have a good workaround, but that's making everyone sad because tests aren't fun when they fail randomly. And there's been a lot of work recently thanks to a grant from the STF and some co-sponsorship from CodeThink, where we've been doing work on GNOME OS, and we've also been working on how to test modules with OpenQA. Because when I ask module maintainers what they think about the OpenQA instance, they always say, well, that's really good, but I don't want to test stuff after I've merged a branch, right? I don't want to merge to master, and then 2 days later you run a test, and then the PR was bad. I want to run the tests during code review. So we've been looking at how to do that. I'm going to have to summarize this again because we're short on time, but the answer basically is systemd sysext. So rebuilding the image every time you make a change is too slow because it's a 5 GB operating system image. But you can build a sysext, and you can overlay it on the base OS that was built, today or yesterday, and then you can test your latest unmerged changes from layered on top of the OS base image. And Martin, who's unfortunately doing a talk right now at the same time as this one, but ask Martin or ask me if you want to find out more about that, because there's some really interesting stuff coming up. And on Monday, there's also a workshop. It's going to be a local and remote workshop talking more about OpenQA testing. So again, I recommend attending that to find out more. And I think that's everything from me. Do we want to go back to the demo, or do we want a couple? How much time do we have? 3 minutes. So we can choose demo or QA, I think. Demo. Everyone here is saying demo. Is that all right? I think I'm going to have to make Jordan the presenter again, though, right? Okay, you're the presenter now, Jordan. You've got...
Thank you. Well, while we were waiting for the questions, I guess.
I'm going to show the chat as well, since we're here. I know.
All right, I'm not sure if you can hear me still, but here's a video of the demo, which isn't very sweet for reasons. The thing, here is a GNOME OS VM, because I was going to do it on my machine, my laptop, but I couldn't figure out how to capture it. The thing we will have to take a better attention here is how light the font is here. Some made a merge request for the GNOME shell to recently change a bit the weight of the font on the lock screen. And the CI CSX bundle that using the CI image and CSX details and all that we created, and we may also paste in the log one line command that you can just copy into GNOME OS, and then it will automatically download the image or overlay it on the system, run a couple of integration commands if they need to be, and afterwards, once you restart JDM to reload the new by the new session from the new user tree, you will notice that the clock on the lock screen is now much more has a much bigger, it's much heavier now, which is awesome. So because designers always were asking, oh, how can I test something, merge request something without having to recompile everything and then recompile WebKit because something starts depending on your version or whatever, just in order to test cell. Now we have like a process that's almost as easy as Flatpak, basically. And yeah, that's it. Any questions? Some you would have to repeat the questions to us.
Okay. Do we have any local questions? Remote questions? Nothing here, I think. Everyone's keen for lunch. Okay, well, thanks a lot for this. This is a milestone, right? A hybrid presentation between Norway, Berlin, and Denver. Thanks a lot for being a part of it.
Excellent.